Hello, my name is Luke Frash. I'm a staff scientist at Los Alamos National Laboratory and an ARMA Future Leader. Today I'm going to be giving a brief overview of the work that I have been doing at Los Alamos National Lab and work that's been published at ARMA throughout the years. In this case, the research contributors include many people from multiple institutions, as you can see here. On the left, you can see an image showing geothermal energy research for hydraulic fracturing, EGS. In this case, you're seeing a fracture pattern that was generated by injection into a granite block and the associated induced acoustic emission cloud. In the center, you can see a video showing a shear fracture being created in a sample of shale. And then the shear fracture is characterized for permeability by flowing through it. In this case, barium carbonate is observed to rapidly precipitate with this flow, producing the white material you see infilling the fracture. This precipitation infilling causes the permeability of this fracture to rapidly decrease. On the right, you can see a picture of myself at the EGS CoLab Experiment 1 site in South Dakota at the Sanford Underground Research Facility. This is a project where we are injecting fluids to stimulate fracture networks to provide a very complete data set for numerical model validation. As an additional overview of the work I've been working on here, you can see on the top left is an image of hydraulic fracture caging for induced seismicity control. This process involves injecting fluids at high pressure, and then they intercept these bounding wells, which causes the fracture to halt growth. In addition, when there's more fractures in the system, this geometry of a well pattern allows you to continuously inject at high pressures without continuously incurring higher and higher risks of large induced seismic events. In the center, you can see a screenshot from GeoDT, which is a recent code that we developed here that is designed to look at coupled geomechanics between stimulation, fluid flow, natural fracture networks, multi-well systems, heat transfer, and ultimately electrical power production. In the bottom plot, you can see fracture branching study. In this case, we're looking at the criteria as a function of injection parameters for when a hydraulic fracture will form as a simple single planar structure versus a more branched swarming structure. The branched swarm structure is potentially beneficial for improved production for oil and gas. In the top right, you can see an example of modeling for well integrity. And on the bottom right, you can see a laboratory setup where we are measuring the initial state of stress in cement as it cures from a liquid solution into a solid at in situ conditions. Thanks for your attention.